Today, we're going over some definitions, some of which are new to you and some of which you've heard since third grade. So, let's begin. I want to start with classifying angles, and I've got the ones that you may already know. A right angle, acute angle, obtuse angle, straight angle, and reflex angle. Okay? So, a right angle, of course, is an angle whose measure is equal to 90 degrees. Acute angle is an angle whose measure is greater than 0 degrees and less than 90 degrees. Then we go to the obtuse angle. The obtuse angle is going to be larger than 90 but less than 180 degrees. Well, then there's a straight angle, and of course a straight angle makes a straight line, okay? So that is an angle whose measure is equal to 180 degrees. And then there's this reflex angle. You may not have heard this one before. A reflex angle is an angle whose measure is greater than 180 but less than 360 degrees. So those are the names of the angles based, the classifying an angle based on its measure. So if I tell you an acute angle, you know where it could be, obtuse and things like that. All right? Now, let's go for another word here. Okay, linear pair. So we're talking about two angles now that share a vertex and a common side where the two non-common sides form a straight angle. So I'm already starting to use some of my words that I have introduced. I have two angles. Boom, boom. And of course, we remember from last time, an angle is made from a set of rays that share a common endpoint, and that's the vertex. So there is one angle. Now, I want to make another angle, and it's going to share one of the sides. Okay, the sides, those are the rays. So side is this is a side, this is a side. Yes? That's the side of the angle. I'm going to share the vertex. But the two non-common sides form a straight angle. So if I share this side here, these two must form a straight angle. So here is angle 1, here is angle 2. I can say that angle 1 and angle 2 are a linear pair. Now, don't fall for this. If I tell you there's an angle that has a 30-degree measure, let's make sure that shows up 30 degrees, and there's another angle over here that has a measure of 150 degrees. I'm going to ask you, are those two angles a linear pair? Those two angles are not a linear pair because, as I have drawn them, I've told you the angle measurements, but they do not meet the criteria for being a linear pair because they have to share a vertex and a common side, and then the non-common sides form a straight angle. I've only told you measures. Notice the definition of a linear pair says nothing about the measures of the angle. They just say that the sides form a straight angle. And of course, if you look back, a straight angle tells you the measure. All right? Now, let's have another new word. I have a word, definition. This is called vertical angles. And vertical angles are two angles formed by intersecting lines that share a common side, common vertex, but not a common side. So they share a vertex, but not a common side. Important that we're intersecting lines. So I've got line 1 and line 2. Anybody could see that two lines that intersect form 4 angles. So I'm going to number them. 1, 2, 3, 4. Now, that's a line, that's a line. From earlier, there are linear pairs, and I have some vertical angles here too. Angle 1 and 2 are actually a linear pair. 2 and 3 are a linear pair because they share a vertex and a side, and the non-common side form a line. Now, these they share a common vertex right here, but not a common side. So we're going to look at angle 1 and angle 3 are vertical angles. Likewise, angle 2 and angle 4 are vertical angles. Now for more angle descriptions. I can also have complementary angles, two angles whose measures sum to 90 degrees, and supplementary angles, two angles whose measures sum to 180. Those I'm sure you've heard before, and if not, then that's shame on your math teachers. But now you've heard them, no reason to forget them. All right, let's move on to lines and describing them, okay? I can have perpendicular lines. That's two lines which intersect at a right angle. And I would like to sketch some perpendicular lines. Here's line 1. And line 2 I'm sketching. And until it's marked, it's not true, so I'm going to mark this. There's a couple ways of writing. I can, at a right angle, I can mark it that they intersect at 90 degrees. I also can mark it with the right angle mark, which is the square in the angle, those two. If I want to say this same thing, that line 1 is perpendicular to line 2, I can say L1 is perpendicular to L2, like that. I can say, if I had points on here, let's see, I can say A and B and C and D. I can say CD line is perpendicular to a B line. And just because they're lines, I know that I can make parts and segments, and those also can be perpendicular. I can name a point here and make it from M to B, be perpendicular from M to D. All right? I can also have parallel lines, just like in algebra. Notice something different here. Two distinct coplanar lines which do not intersect. We have talked about distinct before, meaning different. Coplanar means in the same plane. So we're going to make sure that we keep our lines in the same plane. In algebra, we didn't worry about that, but I do worry about that. So, parallel lines. I'll sketch. Here's line 3 and line 4. If I'm going to mark those as parallel, I mark them with large arrowheads. And that tells me those two lines are parallel. If I have another set of lines that are also parallel, and maybe not parallel to 3 and 4, maybe they're going this way, I might use 2 because I don't want to get anybody confused that this one's parallel to this one, because obviously it looks like they intersect. Okay, another way of writing it symbolically, I can say line 3 is parallel to line 4. All right? Now, you may think, all right, why did I have to include that coplanar? Well, there's another word for lines that do not intersect and they are not parallel, and that's called skew lines. Skew lines, well, the best way for me to show you this is to sketch a cube. All right, I'm going to sketch a cube, make it isometric. There's a line that follows this edge. Let's say that line 5 follows this edge. There's another line that follows this edge. Those two lines never intersect. Those two lines are also non-parallel. So those two lines are skew lines. Line 5 is skew to line 6. Now we're moving on to polygons. And first off, I need to define what a polygon is. A polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint. And I have drawn 2 polygons here. You'll notice that the line segments are all connecting. It's not open. It's a closed figure. There's no spot that you can come in and out or anything like that. And it's endpoint to endpoint. And of course, it is in a plane. I've kept it flat. Now, this polygon is not the same as this, and we have words to describe their difference. Excuse me. This one is called a convex polygon, and this one is called a concave polygon. Now, I need another word to help define the difference between convex and concave. You might look at the pictures and say, well, this one's dented in and this one's not dented in. Well, okay. I am going to use another word that helps me. First off, I want to look at these vertices. These vertices, let's put some letters on here. A, B, C, D, E, F, and G. And I'll do the same letters over here. Maybe I shouldn't do the same letter, G, unless we'll do H, I, J, K, L, M, and N. Different polygons, different points. I have all those points, and D and E are next to each other. Yes? The word for next to in mathematics was actually, there's 2 words. One of those words is adjacent. Another word would be consecutive. Consecutive. I use those interchangeably. Adjacent means next to. You have someone sitting adjacent to you in my class. It's hard to say that you have one sitting consecutive to you. Consecutive is like from last year, we have consecutive numbers and we have consecutive values in a sequence. So these are consecutive. If I'm naming these, the ones that are consecutive are the ones that are adjacent. Okay? And the word I need to help us with is diagonal. And a diagonal is a line segment connecting two now I can say non-consecutive or non-adjacent, either one. I'll say non-consecutive vertices in a polygon. We had a problem the other day, and some people were asking me, what does diagonal mean? So that's exactly what it means. There are diagonals. GD, if I connected that, would be a diagonal. GF is not a diagonal. GA is not a diagonal. So because we have to have non-consecutive vertices. GF is called a side. GD is a diagonal. GC is a diagonal. Now, if I move to the concave, I still have consecutive vertices, which make sides. I can make a diagonal by going across. Now, notice something here. I have a special diagonal that goes from J to L. That's a diagonal. That diagonal steps outside of the polygon. It's on the exterior. And that's how I'm going to define what convex and concave. A convex polygon, all diagonals must be in the interior. A concave polygon has at least part of a diagonal on the exterior. If I close this up, at least one part of a diagonal must be on the exterior. All right, so we have diagonal, we have polygons, we have concave, convex. We can also classify our polygons by the number of sides. You've already been doing this. You know that if it has 3 sides, it's called a triangle. 4 sides a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7, wait, there's 2 names, a septagon and a heptagon. 8 is an octagon, 9 is a nonagon, 10 is a decagon. Then, bonus, 11 is called an undecagon or an undecadon. Okay, 12 is dodecagon, and that's as far as I'm going to require you to memorize. Guess what? I have a feeling that you probably have most of those memorized. And if you don't, I'll help you. Because there's months, there's October, November, December, right? Those come together, oct, non, December. Oh, and that's the 8, 9, 10, yeah? So those help me out like this. So those will, and 11 is like, this is like un or on or uno. It's like 1 and 10, right? So it's 1 plus 10. So it's 1 and 10 if you're taking your language. And 2 is dos, do, things like that. So it's 2 plus 10. That's how I remember it. All right. Now, those are the names that I need you to memorize, but for now, you'll be fine looking at your notes. One thing about polygons, here we go. If 2 polygons are congruent, then corresponding sides and angles are congruent. So, what does it mean? Well, last time we talked about what congruent means. That's the same shape and the same sides. So if I have 2 polygons that are the same shape and the same size, well, they match. Well, how do they match? And this is what corresponding means. I have to have them line up together, okay? And I've written out that quadrilateral fish is congruent to quadrilateral camp. Now, there's no picture here, but I can make some presumptions based on this information. I know that angle F must be congruent to angle C because those two correspond. Angle I must be congruent to angle A. Angle S is congruent to angle M. And angle H is congruent to angle P. Because they're congruent and because I wrote them in this pattern, then this must be true. So these are adjacent to each other. That's a diagonal, that's FS, which is a diagonal over here. There's CM. All right. Also, those are the angles. It says the sides. So if I look at side FI, it must be congruent to side CA. And IS is congruent to AM, SH congruent to MP, and of course FH over here is congruent to CP. That is not knowing what the quadrilateral looks like at all. This must be true. If I tell you that they're congruent, then you can assume all of this stuff. All right? I have some other words for polygons, most of which you've heard. The word equilateral means that all sides are the same length. Okay? Fantastic. Equiangular means that the angles are the same length. And the word regular means that it's both equilateral and equiangular. So I can put these together with the number of sides words. So I can have equiangular pentagon, a regular nonagon. I can have an equilateral triangle. So that's how it helps me classify them so you know what they're talking about, what I'm talking about, in the picture that we're talking about. And finally, we can talk about triangles, probably what you're most familiar with. We have triangles. We have a right triangle, which means that there is one right angle. An isosceles triangle has two congruent sides. A scaling triangle has no congruent sides. No two sides are congruent. An equilateral triangle is a regular triangle. Oops. And I just told you what regular means, so you can review that if you need to. An obtuse triangle. There is one obtuse angle in an obtuse triangle, not two. An acute triangle, all three angles are acute. So there you go. I know there's going to be a lot of writing down. I tried not to make it too long on you. All right, we will see you and work on this next class.